So, yeah. So I mean, yeah, you have to be careful of what you're doing. So let's save it just so we don't lose any information. So that's so now we need to define our sections. So define frame sections. We can add a new property. Actually, you know what, before that we have to go, as I said, exactly start from left to right, top to bottom. So let's not skip anything. Let's define materials first. So it already has a 4,000 PSI concrete material, and I think that's what we have in our problem.
It's the second part.
Was it 4,000 PSI?
Yeah, it's right there.
Yeah.
Number 3.
Yeah, 4,000 PSI. So yeah, it's 4,000 PSI, and we can look at it, make sure everything is right. Modulus of elasticity looks right. It uses the same equation we use, 55,000 square root of F prime C. That's F prime C. And if we go to pound foot, you can keep changing. See, it's assuming a unit weight volume of 150 PCF. Right, that's a weight per unit volume. If I go, so I can change the units. I can do a lot of things instead. So I don't need to define a new material because it's already there. If it was 3,000 PSI, then I would have to add a new material, and then I have to go here and add new material, tell it it's concrete, and then change. You can change here to 3,000, 5,000, and so on. And click OK, and you're done. But here it's 4,000, so it's already set because that's common. Here in the US, most of the concrete we use is 4,000 PSI. So I don't need to do anything. So now we need to define sections. So frame sections, I have columns and I have beams. And there's something tricky about this. It can take us maybe 10-15 minutes to discuss about how we model this whole thing. So first, let's look at the columns. We have the columns, we assume they're 12 by 12, and these beams are 10 by 20. So we need to define a section for the column and another section from the beam. So I need to add a new property and check the material type. It's concrete and it's rectangular. And here I don't want to go kip foot, so I can just get out and change here to kip inches because I want to put the units in inches. I don't want to put units in foot and get divided by 12. I don't want to do it. So add a new property, concrete, rectangular. Our concrete section, it's 10 by 20, right? So you guys remember before we put any values, you guys remember I told you I try to draw my columns from bottom to top and beams from left to right and be consistent. And that's for a reason. That's because you guys will learn that if you take course structural analysis too. We teach this stuff. So the way SAP looks at it is that I draw that from bottom to top. It assumes that's I, calls it I, which is the start node. And then the second node, since I went from bottom to top, calls it J. And for element 1, that's going to be I, that's going to be the start node, that's going to be the end node. And then you get into something called local axes. Each element has its own axes. You're going to get an axis 1, and then you would have another axis that is actually in this direction. It's going to be axis 2. And then you have a third one based on a right hand rule. It's going to be axis 3. So each one has its own local axes, and we can see these local axes if you go to the display. You look at frames, you can check local axes. It shows you these axes. So the red one is axis 1. Actually, here the green is 2, and then the third one is axis 3. If I want to look at it in 3D, that's what it's going to look like. So that's axis 1, 2, and 3. So, yeah, not to confuse you, just maybe use the same colors SAC is using, but it's the same numbers. So that's going to be axis 2, that's going to be axis 3. Call that the local axes. It's called local axes, 1, 2, and 3. So each member has the same thing. Like, look at this beam, it's the same exact thing. I started here at I, ended at J. So you have axis 1, and then you have axis 2, and then you have 3. So that's 1, 2, and then 3 out of it. So each one has its own local axes. So let's cut a section at any of these members. When you cut the section, that's what you see. That's your section, rectangular section. What you see is axis 3 is actually the x-axis. Axis 2 is the y-axis. Axis z is in this direction. So axis 3 is acting as the x-axis. And then SAP and all other software work the same way, because that's the finite element. Specifies this height, calls it T3, because it's the height is perpendicular to axis 3, and that's 2, and the width is T2. So that's where you go to define section properties, frame section. So you define section properties, you add a new property, and you go to concrete. You see you have a T3 and T2. The T3 is the depth, T2 is the width. So always look at it this way. That's why we call it T3 and T2, because of the local axes. Yeah.
So the axes are based on your start node and end node, right?
Yeah.
The direction that 2 is pointing is not the same relative. So which way is 2 pointing?
Here 2 is upwards.
Right.
Yeah.
So then if you rotate it.
This one, 2 is going to be in the other. So 1, yeah. So that's a good question. 1 is always in the direction of the member. So if it's a vertical member, it's going to be upwards. It's horizontal, it's going to be horizontal.
Mm-hmm.
And then 2 and 3. 2 is going to be in the same plane, XD plane, and then 3 is going to be out of plane. That's how separate. But I mean that's not the point. That's just I wanted to show you what's T3 and T2 represent. But I mean, yeah, but that's something has to do because you do your computation, something called, stiffness. You get the stiffness of the member and do stiffness assembly, and that's